Good morning everyone, Miss Martin here. So this video is for anyone that's not able to join our live chat today, and I'll just walk you through some of the things we talked about for our discussion and review what low pitch and high pitch sound waves look like. So let's take a look. So our big goal, I can explain how the length of sound waves makes high and low pitch sounds. So on Monday, we talked about a few important things. Now that video was kind of long, and I had a few of us go back and try it again, just to make sure we got all the information we needed. So the first three questions was, what does volume mean? What does pitch mean? And what difference did you see between the low pitch and a high pitch string vibration? So what does volume mean? Volume is how loud or soft a sound is. So right now I can go to my computer, I can find the volume button, and if I want this to be louder, I'll click the button up and I'll make it louder. And if I want this to be softer, I'll click the button down and have lower volume. What does pitch mean? Pitch is how high of a note or how squeaky the note sounds and how low of a note. It would sound more like a bass, okay? So I like to compare squeaky to like a mouse, like the sound of a mouse, and a low note, kind of like the sound of a whale. All right, if you're thinking about it with musical instruments, flutes make a high-pitched sound, and tubas make a low-pitched sound. What difference did you see between the low-pitch and high-pitched string vibration? So this is when we were looking at the guitar strings. The string vibrates faster for high pitch and slower for low pitch. So let's get into this difference right here. I had a lot of people who were kind of confused about the difference between volume and pitch. All right, so volume is how loud or soft a sound is. So I'm going to show a low volume. I'm going to whisper right now. It's really hard to hear me. And then a loud volume is what I'm going to raise my voice and I'm going to shout. So those are the big differences between loud or soft or high volume, low volume. Volume's all about the level of sound. Pitch is how high or squeaky or how low a note sounds. So that's when I think about my mouse versus my whale. Whales talk much lower. And mouses have a high, squeaky kind of sound. So let's review the second part. This part was the part that was confusing for a lot of people. What I was looking for is, these were the three questions about each type of pitch, and I was looking for answers for each three. So the questions are, is the vibration fast or slow? Does the sound wave look squished together or spread out? Is the wavelength long or short? So for high pitch, the vibration is very, very fast, so it's shaking very quickly. The sound wave, since it's so fast, is squished together. And then the wavelength is the measure between the top of one curve and the top of another. And as you can see, it's actually pretty short. We squished a lot of waves together, so it has short wavelengths all squished together. Same deal with the low pitch. Is the vibration fast or slow? Does the sound wave look squished together or spread out? Is the wavelength long or short? In this case, complete opposite. The vibration is slow. The sound wave, since it's slower, doesn't go up and down as much, so the wave itself is more spread out. And then if we were to compare the wavelength, it has a much longer wavelength. So from the top of one wave to the top of the other, it's much longer. So what does wavelength mean? I want to go into this in a bit more detail. So the wavelength is the distance between the crest of one wave and another. So here's the top of one wave, here's the top of another. The wavelength is this distance right here. So which one has the longer wavelength? Here's a quick drawing I made. High pitch, since there's more waves squished together, the wavelength is much shorter. There's a much shorter distance between one wave or another. Low pitch, you get a much longer wave because there's a much greater distance between the top of one wave and the top of another. So in the Waking Waves experiment that you watched yesterday, I used a rope, and if you had a rope at home, you could have tried this as well, and I tried to replicate what a high-pitch wave would look like and what a low-pitch wave was. So what type of wave did I have to move my hand the fastest for? Was high-pitched. So that tells me A high-pitched vibration is a faster vibration. What type of wave did I have to move my hand the slowest for? That was low pitch. So a low pitch vibration is much slower. So I posted a virtual oscilloscope under Fun Science Activities on Google Classroom. Let's see if we can make some high pitch and low pitch waves. So let me pull this up. Okay, so when you're just talking, there is a lot of different pitches, so you can see the oscilloscopes kind of bouncing all over the place. So let's try a high-pitched sound with just a single tone, like a whistle. Let's try that one more time. So you can see it made a lot of little waves all squished together. Now let's try a low tone, like, let's go for a cow moo. If we were to take a snapshot between the high pitch and the low pitch, you would see that the high pitch has much more waves all squished together. When we're done this, you can go and click on that link. It's underneath Google Classroom, and you can experiment with some different sounds yourself. But remember, it's got to be a solid note, like ah. Even that one kind of bounces around a bit. All right, so let's review. High-pitched sounds have much shorter wavelengths, and that's because of a fast vibration. It all leads back to that vibration. Low-pitched sounds have long wavelength, and they have a much slower vibration. So when we get done here, I want you to go and answer the questions on your assignment, and then click the turn in button. If you have any other questions, please record a Flipgrid, and I'll get back to you today. All right? Thank you guys for joining me today.